law. Ideal gas law we talked about in that lab. PV equals nRT. And just as a reminder what everything stands for so you're not confused on any of them. P is pressure. V is volume. T is temperature. N is number of moles, which is basically a measure of mass of a gas. Mass of the gas, and R is the gas constant. And the value for it is 8.314. It's actually a reasonable number, believe it or not. In a world where none of our numbers are reasonable in this unit, this one is. One other note I want to make on this for y'all is this is the only equation where T is in Celsius. Everything else is in Kelvin. This one is in Celsius. Okay, and the reason for this is very simple. We measure specific heat. Oh wait, hold on. Nope, I wrote this on the wrong one. Sorry, I apologize. This one is in Kelvin. We'll get to heat transfer in a second. This is the one where temperature is in Celsius. That's my bad. Okay. Very few of these problems are you actually solving out numbers. In fact, most of the things where you're solving out stuff we did already earlier in the unit, calculating temperature and that kind of stuff. So for these kind of questions about PV equals nRT, it's basically can you explain what's happening? So number one, what should happen to the pressure of a gas if the temperature is raised but the volume of the gas container and the amount of gas remains unchanged? Okay, so the easiest way to answer this is to just look at the equation and see if you can figure out what would happen if you change one thing but don't change the others. So what would happen to pressure P if the volume, if the temperature is raised, so if you make it hotter, but you don't change the volume and you don't change the amount of gas? What would happen to the pressure? That may be very easy for you to answer. Okay. If it's not, make up numbers. Okay. What would happen to the pressure of the gas? The pressure starts at 1. The volume is 1. The number of moles is 1. R is 8.314, and the volume or the temperature is 1. There we go. Okay. I'm solving for the pressure. Okay. Well, the pressure is 8.314. Okay. Easy enough. Let's change it where we increase the temperature now. So pressure, volume stays at 1. Number of moles stays at 1. R is a constant, 8.314. And let's increase the temperature to 2. Let's be crazy. Well, if we did that, the pressure becomes 16.628 pascals. And you can see what happens to it as it increases. I don't know whether I'm doubling it or not, so I'm just writing that it's going up. And if I look at the equation, that makes sense. These are directly proportional, we talked about in the lab, so increasing one will increase the other by the same amount because we're keeping the other two things constant. Because we kept the volume the same, because we didn't add or remove any particles, then increasing the temperature is simply going to increase the pressure. Okay? I want you guys to try two. Elephant sits on a yoga ball. Yep, even elephants need to attain internal harmony and oneness with nature, causing it to compress. What should happen to the pressure in the ball if its temperature and amount of gas remain unchanged? So this time we're changing the volume. We're still keeping the amount of gas in it the same, and we're keeping it the same temperature. Okay? What would happen? Go ahead and take a minute, answer that one. Okay. What do you think? Zoe, what do you think? What's going to happen to the pressure? Yes. When we compress it, we're squeezing the particles together. If we're not changing the temp and we're not changing how much energy there or how many particles there are, then the pressure has to go up. So the pressure would increase. And if I ask you to explain it, you could either do what I did up here, make up numbers, and see what happens if you change the volume. Or you could say that P and V are inversely proportional, which we've talked about. Okay. Any questions on that one? So this is mostly an equation that you're going to do as concepts. Perfect. All right. Let's jump down to heat transfer.